detail now. And so John needs to pay $10, and he has an unlimited supply of $2, $5, and $10 bills. And so we're trying to find the number of ways he can pay for the money. And so we can set some variables. So you let him pay A, $2 bills, B, $5 bills, and C, $10 bills. And so in order to pay $10 exactly, the A, B, and C variables must satisfy 2A plus 5B plus 10C equals 20 and 10. 2010. And so if we look at this mod 2, you can see that 5B is congruent to 0, and so that means B is congruent to 0 mod 2. And also, if you look at this mod 5, you get that 2A is congruent to 0 mod 5. And so what this means is basically you get that A is congruent to 0 mod 5. And so B is congruent to 0 mod 2 basically implies that B is in the form 2 times B prime. And A is congruent to 0 mod 5 implies that A is equal to 5A prime for some A prime. And in both of these places, B prime and A prime are non-negative. Because it's possible that he paid $10 bills, or $2 bills, or $5 bills. And so you can plug both of these back into this equation. And so 2 times 5A prime plus 5 times 2B prime, plus 10C is equal to 20 and 10. 2010, sorry. And so that gives 10A prime. Okay. So that gives 10A prime plus 10B prime plus 10C equals 20 and 10. And if you divide this by 10, you get A prime plus B prime plus C equals 201. And so the only restrictions on the A prime, B prime, and C here are that A prime, B prime, and C all satisfy them being non-negative. It's possible for him to pay 0 of the kinds of bills. He doesn't need to use all 3 kinds. And so that just means that this is basically a classical stars and bars problem with 201 stars and 2 bars. And 2 bars is because there's 3 values, and the number of bars is 1 less the number of things that you're splitting into. And so
may I remark that the bars can also be called dividers?
Yeah. Bars, dividers, yeah. They're referring to the same thing. And so that would just mean that the answer is 203 choose 2, which is 203 times 101. And if you want to expand this, it's 20,503. And so that's the answer for this question. So now I'll start going over the level 4 question. So we're given that A, B, and C are positive real numbers. And so we want to show that 2A plus B plus C squared divided by 2A squared plus B plus C squared plus 2B plus C plus A squared divided by 2B squared plus C plus A squared plus 2C plus A plus B squared divided by 2C squared plus A plus B squared is less than or equal to 8. So first of all, we can notice that the degree of each of these three terms is all 0. And that's because the degree of all of the terms in the numerator and the degree of all the terms in the denominator are all 2. And so 2 minus 2 is 0. And so the degree of each of these terms is 0. And so that means that this inequality is called homogeneous. And homogeneous just means the degrees of all the terms are equal. And so because the inequality is homogeneous, we can set an additional constraint. And this is called normalization. And so I think it's called normalization. And so without loss of generality, you can just set a plus b plus c to equal something like 3. Because normalization, basically you can set one expression using the variables to equal anything that you want. And that's because if the set AB of solutions ABC works, then any set of solutions KA, KB, KC for some constant C also works. And so if you do that, you can manipulate it into this eventually being true. And so now that you've assumed this side just simply becomes a plus 3 squared divided by 2a squared plus 3 minus a squared. Sorry, hold on a second. Sorry about that. So plus b plus 3 squared divided by 2b squared plus 3 minus b squared plus c plus 3 squared divided by 2c squared plus 3 minus c squared is less than or equal to 8. And so now we can expand this. And so what that would give us is a squared plus 6a plus 9 divided by 3a squared minus 6a plus 9. And plus b squared plus 6b plus 9 divided by 3b squared minus 6b plus 9 plus c squared plus 6c plus 9 divided by 3c squared minus 6c plus 9. And so we can further simplify this into 1/3 plus 8a plus 6 divided by 3a squared minus 6a plus 9. And so the same would apply to these other three terms, these other two terms. And so those equal 1/3 plus 8b plus 6 divided by 3b squared minus 6b plus 9 plus 1/3 plus 8c plus 6 divided by 3c squared minus 6c plus 9. And so you can see that these just add up to 1. And so now if we want to show a relationship between this is less than or equal to 8, we need to focus on the terms like this. And so if we look at these terms, first of all, we can see that 3a squared minus 6a plus 9 is equal to 3 times a minus 1 squared plus 6. And so this is at least 6. And what that means is that 8a plus 6 over 3a squared minus 6a plus 9 is at most 8a plus 6 over 6. And that's because since the denominator is at least 6, that means that the maximum value of the fraction itself is when the denominator is at a minimal value. And so what that means is that this expression is less than or equal to 1 plus 8a plus 6 over 6 plus 8b plus 6 over 6 plus 8c plus 6 over 6. And this is equal to 1 plus 4 thirds of a plus b plus c plus 3. And since up here we already assumed that a plus b plus c equals 3, so then we have that this is equal to 1 plus 4 plus 3, or 8. And so this shows that 2a squared plus 2a plus b plus c squared over 2a squared plus b plus c squared plus 2b plus c plus a squared over 2b squared plus c plus a squared plus 2c plus a plus b squared over 2c squared plus a plus b squared is less than or equal to 8.